Hello Internet, today we have this Gigabyte 3080 Ti and today we're going to find out how likely is it that the GPU as such would survive a power surge. We already know for a fact that a lightning strike that would burn your HDMI port will render your GPU a complete toast. Nothing, absolutely nothing on the board would survive. The board itself becomes absolute garbage, not even good for any kind of parts, except maybe for some connectors. Not a single capacitor, resistor, or anything on that board is salvageable. But this one had been died, according to the customer, after a power surge. So it kind of makes me wonder if this one had survived. Chances are very low, but we're going to find out one way or another. So we're gonna turn on the multimeter, do some basic measurements before we go anywhere too far into this, starting with 12 volt here. That's the ground. Okay, so this looks like an open line, and this one looks like it's reading some kind of a charging rate of the capacitor. As you can see, we can follow this curve, but nothing here. That means something blown, most likely a fuse got blown, and probably a driver MOSFET. I think this here is memory. That reads good. This here is PEX. That reads good as well. And I am beginning to think that this might actually survive. 1.8 reads good. 12 volt here reads good. And one last measurement, 5 volt. Very interesting. 5 volt reads a little bit low. That could potentially be because of that faulty driver MOSFET that's lowering the reading of the 5 volt rail, because that MOSFET is not only linked to 12 volt as its main source of power, but it also linked to 5 volt that is used to actually power the driver MOSFET as well as enable it and do all sorts of other things. So let's take the cover off, look underneath and see what we find. At this point, I wonder, since we already know that Gigabyte phase number 8 keep constantly blowing out due to incorrect circuit design and specifically one component that's soldered onto the board that's not supposed to be soldered there at the factory, if they didn't know it, then why in the world did they put this this cooling pad that cools specifically this area and nothing else? Why do we not have it cooling anything here or anywhere across, like at the very top or at the very bottom? Because if you can see here, that pad seems like it's strategically placed just to cool the general area where the driver MOSFET is, almost as if they knew they screwed up at the factory at the assembly line, and instead of going through every single card removing this capacitor, they ended up placing a thermal pad that would make the GPU work for a little bit over the warranty period, so that way you'll be forced to buy new. I don't know, that's just theory. Regardless, we want to see if that is indeed the case, and I think it is. We have that one capacitor there. Yep, that I believe the capacitor is there, and but we have to have a very specific controller on here. I cannot really read this. We need to go under a microscope and see if this is the controller that would tell us whether or not that capacitor is supposed to be there to begin with. And let's see. And this is, it's a 9511R. And as we can see here on the right, this is the only capacitor that's linked to the feedback circuit for that one particular phase. So that capacitor does not need to be here. So let's go and remove this really quick.
That was quick.
And that should be it. The problem should not repeat itself afterwards. And I am guessing the driver MOSFET that's blown is going to be 8th one as usual. So we're going to start counting from the bottom. We'll go 1, 2, 3, 4, 5, 6, 7, 8. It's going to be this guy here. But I don't know. Most likely that's the guy. And as a matter of fact, if we can look at it here on an angle, we can already see a bulge and a sign of a blowout here on the side. And also the confirmation to that would be we have an open line on this fuse, I believe. This one here. Yes, there you go. No reading on this fuse. See right there, there's nothing on this fuse. So the fuse is blown, the driver MOSFET is blown. We can take a closer look at this driver MOSFET under a microscope. There is our, get the better lighting here. Yep, there's a bulge and a sign of a blowout. Now what makes this repair worse compared to other cards is that I cannot just desolder that one driver MOSFET. I actually have to physically remove it with a grinder, such as this one here. So I'm going to have to be grinding this thing out of the board. If I try to remove it with just heat melting the solder, it's not going to go anywhere because it is actually welded to the board. So the only way to get this is to separate from the board using a grinder, such as this one, and then solder a new one on top of it. So let's remove the goggles and see if that helps. And we're going to be replacing the fuse as well in the process. Alright, this is what we have left with. Here, remove the driver MOSFET from the board.
Some big testicles to pull this off every day.
The new one is on there, as you can see, and the fuse. Okay, let's see if we have any shorts on the board. Looks good, and looks good. And what about 5? 5 is now reading a little higher value than before, as suspected. Okay, let's power it on, see what it does. Hopefully this is it. Let's use the oscilloscope to verify that the phase is working correctly by comparing it to the neighboring phase. So here's the one that we replaced, and here's its neighbor, as well as all the other phases are working as the rest of them, except for this one. This one's a memory. So is this, another core, and let's see if this thing will post, and hopefully that's it for today. And I think it's posting. We already noticed the line on the screen, and there we go. Alright, so all that's left now is to put this thing together, run some tests, make sure this does not crash, and if it does, we'll have to reball the core, probably. Doubt it, but you never know. So that will be it for this repair. Thank you for your attention, for all the love in the comment section below. And don't forget to like, subscribe, comment below as usual, and I'll see you later fixing something else. Goodbye.